Welcome to the session on theory of equations. In the previous sessions, we discussed some results of theory of equations. Here, we shall do some example problems on theory of equations. First one is, solve the equation x cube minus 13x square plus 15x plus 189 is equal to 0, given that two of its roots differ by 2. A condition is given which is two of its roots differ by 2. This is the given condition. We have to solve this equation. Here the given equation is third degree equation. Therefore, by the fundamental theorem, this equation has 3 roots. A condition is given which is the two of its roots differ by 2. Assume that alpha minus 2 and beta are the roots. Then in the previous session we discussed the relation between the coefficients of this types of equation and the roots of the given equation. Here the 3 roots are alpha, alpha minus 2 and beta. Therefore, we can write S1. S1 means sum of these 3 roots, that is alpha plus alpha minus 2 plus beta, which is equal to minus 13 minus of minus 13 divided by 1. That is, this implies from here we can write alpha plus alpha is 2 alpha plus beta minus 2 is equal to 13. Let it be equation number 1. Now S2 means the sum of the product of 2 roots taken at a time, that is alpha into alpha minus 2 plus alpha minus 2 into beta plus alpha into beta. But by the relation we discussed in the previous session, we can write this S2 as 15 divided by 1. That is, this implies from here we can write alpha into alpha is alpha square minus alpha into 2 is 2 alpha plus alpha into beta minus 2 into beta plus alpha into beta is equal to 15. That is alpha square minus 2 alpha plus here alpha beta plus alpha beta means 2 times alpha beta. Therefore, we can write from here we can write 2 alpha minus 2 into beta, because alpha beta plus alpha beta is 2 times alpha beta, then minus 2 into beta. This is equal to 15. Let it be equation number 2. Now, using these 2 equations, that is equation number 1 and equation number 2, we can eliminate beta from this using these 2 equations. We can write from these 2 equations, we can write from first equation and 2, we will get 3 alpha square minus 32 alpha plus 45 is equal to 0. From here we can write beta is equal to 13 plus 2 minus 2 alpha, and substituting the value of beta in this second equation, then we will get this equation, that is 3 alpha square minus 32 alpha plus 45 is equal to 0. That is, we can write alpha minus 9 into 3 alpha minus 45 is equal to 0. On factorizing this left hand side, we can write alpha minus 9 into 3 alpha minus 45, not 45, this is 5. 9 into 5 is 45. Therefore, alpha minus 9 into 3 alpha minus 5 is equal to 0. That is, we can write alpha minus 9 equal to 0, or 3 alpha minus 5 is equal to 0. From this, we can write alpha is equal to 9, or alpha is equal to 5 by 3. On solving this equation, we will obtain alpha is equal to 9 or alpha is equal to 5 by 3. But alpha is equal to 5 by 3 is not admissible, because when we substitute alpha is equal to 5 by 3, that is alpha means the value of x. When we substitute x equal to 5 by 3, this equation does not satisfy. Therefore, we can take alpha is equal to 9. Hence, the required roots are, we have taken the roots as alpha, alpha minus 2 and beta. Therefore, when alpha is equal to 9, we will get from this first equation beta is equal to 2 into 9 minus 2 minus 13, or beta is equal to 13 plus 2 minus 2 alpha, that is beta is equal to 13 plus 2 means 15 minus 2 into alpha is 9, that is 15 minus 2 into 9 is 18, that is minus 3. Beta is equal to minus 3. Therefore, we can write the required roots as alpha, alpha minus 2 beta, that is 9 minus 2 and minus 3. That is, the required roots are 9, 7 and minus 3. These are the 3 roots of the given equation. Now, consider another example. Solve the equation x raised to 4 minus 12x cube plus 14x square plus 132x minus 135 is equal to 0. Given that the roots are in AP, the given condition is all the roots are in the arithmetic progression AP. Assume that the roots are here, the given equation is of 4th degree. Therefore, by the fundamental theorem, we can say that this equation has 4 roots. The given condition is all the roots are in AP. Therefore, we can assume the roots as a minus 3d, a minus d, a plus d and a plus 3d. We can write S1. S1 means the sum of the roots taken one at a time. That means the sum of these 4 roots, that is a minus 3d plus a minus d plus a plus d plus a plus 3d. By the relation, we can write S1 as minus 12 divided by 1, that is the coefficient of x cube divided by the coefficient of x raised to 4, that is 2 minus of minus 12 divided by 1. is equal to, from here we can write a plus a is 2a, plus a is 3a, plus a is 4a, minus 3d minus d means minus 4d. Here d plus 3d is plus 4d, therefore minus 4d plus 4d will become 0. Therefore, we can write 4a is equal to 12, which gives a is equal to 12 by 4, that is 3. A is equal to 3. Now, from the relation we can write the relation between the roots and the coefficients of the equation. We can write S4. S4 means the sum of the products of 4 roots taken at a time. That means a minus 3d into a minus d into a plus d into a plus 3d. That is S4 is equal to minus 135 divided by the coefficient of x raised to 4. We can write minus 135 divided by 1 means minus 135 itself, which is equal to a minus 3d into a plus 3d, that is a square minus 3d square, that is 9d square, into a minus d into a plus d is a square minus d square. That is we can write from here we obtained a as 3. Substituting a is equal to 3 here, we can write this equal to 9 minus 9d square into 9 minus d square. The left hand side is minus 135. From this we can write 9 minus 9d square into 9 minus d square means d raised to 4 minus 10d square plus 24. Is equal to 0. From this equation, on multiplying these two, we can write d raised to 4 minus 10d square plus 24 is equal to 0. That is d square minus 4 into d square minus 6 is equal to 0. On factorizing this, we can write d square minus 4 into d square minus 6 is equal to 0. From this we can write d square minus 4 is equal to 0 or d square minus 6 is equal to 0. That is d square is equal to 4 or d square is equal to 6. That is d is equal to plus or minus 2 or d is equal to plus or minus root of 6. If we take d is equal to plus or minus root 6, then the assumed roots become, from here we can write a is 3 minus 3d and 3 plus 3d. Therefore, we can write 3 plus or minus 3 root 6 and 3 plus or minus root 6. That is a minus d, a plus d, a is 3, d is equal to plus or minus root 6, which do not satisfy the given equation. When we take d is equal to plus or minus root 6, then the roots will become like this: 3 plus or minus 3 root 6 and 3 plus or minus root 6. These 4 roots does not satisfy the given equation. Therefore, we will take d is equal to plus or minus 2, and the required roots can be written as these are the assumed roots. A is equal to 3 and we will take d is equal to plus or minus root 2. Therefore, the required roots can be written as 3 minus 3 plus or minus d is 3 into 2 and a plus or minus d. A is 3. That is 3 plus or minus 6 and 3 plus or minus 2. From here we can write 3 plus 6. 3 plus 6 is 9 and 3 minus 6 is minus 3. 9 minus 3. From here we can write 3 plus 2 is 5. 3 minus 2 is 1. The required roots are 9, minus 3, 5 and 1. In order we can write minus 3, 1, 5 and 9. These are the roots. We can verify this. This is in AP because the common difference is 4. Therefore, these are the 4 roots of the given differential equation. X raised to 4 minus 12 x cube plus 14 x square plus 132 x minus 135 is equal to 0. Now, consider another example. Solve the equation x raised to 4 plus 4x cube minus 5x square minus 8x plus 6 is equal to 0. Given that 2 of its roots are equal in magnitude but opposite in sign. The given condition is 2 of the roots are equal in magnitude. Equal in magnitude, but in opposite signs. The given equation is of 4th degree. Therefore, by the fundamental theorem, we can say that this equation has 4 roots. Among the 4 roots, the 2 of them are equal in magnitude, but opposite in signs. Assume the roots are alpha, minus alpha, beta and gamma. Because the given condition is the 2 of the roots are equal, we take alpha and minus alpha, but in opposite signs. Therefore, we take alpha and minus alpha as the 2 roots, and the other 2 is beta and gamma. From the relation between the roots and coefficients of the equation, we can write S1. S1 means the coefficient of x cube divided by the coefficient of x raised to 4, negative of the coefficient of x cube divided by the coefficient of x raised to 4, that is S1 is equal to minus 4. But S1 is the sum of these 4 roots, that is alpha plus minus alpha plus beta plus gamma, which is equal to minus 4, that is beta plus gamma is equal to minus 4. Now, we can write S3. S3 is equal to minus 8 divided by 1, that is the coefficient or negative of the coefficient of x divided by coefficient of x raised to 4, that is equal to 8. But S3 means the sum of the product of the 3 roots taken at a time. Therefore, we can write S3 as alpha into minus alpha into beta, that is minus alpha square beta, plus minus alpha or alpha into gamma, that is minus alpha square gamma, plus alpha into beta into gamma, plus minus alpha into beta into gamma, that is minus alpha beta gamma. S3 is the sum of this product, that is the terms are the products of 3 roots taken at a time, which is equal to 8. That is alpha beta gamma and minus alpha beta gamma will become 0. From here we can write minus alpha square into beta minus gamma, sorry, beta plus gamma, because here the sign is negative. Alpha into minus alpha into gamma means minus alpha square gamma. Therefore, we can take minus alpha square into beta plus gamma is equal to 8. This equation be denoted by 1 and this be equation number 2. From equations 1 and 2, we can write minus alpha square into beta plus gamma is minus 4 into minus 4 is equal to 8, or 4 alpha square is equal to 8. This gives alpha square is equal to 8 by 4, that is 2, which gives alpha square is equal to 2 means alpha is equal to plus or minus root 2. When we substitute this root, that is root means the value of x, when we substitute x is equal to plus or minus root 2, this equation will be satisfied. Therefore, both plus root 2 and minus root 2 are the roots of the given equation. Therefore, we can write the factors as x minus root 2 and x plus root 2. And the left hand side of this equation can be expressed as x minus root 2 into x plus root 2 this into x square plus lambda x minus 3, which is equal to 0. That is from here we can write x square minus 2 into x square plus 2, this into x square plus lambda x minus 3 is equal to 0. This is the given equation, and we expressed this equation like this. Therefore, these two equations are identical. We can equate the coefficients of x, and we will get from here minus 2 lambda x, here minus 2 into lambda x. Therefore, we can write minus 2 lambda is equal to minus 8. In this the coefficient of x is minus 8. Minus 2 lambda is equal to minus 8 means lambda is equal to 4. Therefore, the remaining two roots are given by given by the equation x square plus lambda x minus 3 is equal to 0. That is x square plus 4 into x minus 3 is equal to 0. By solving this equation, we will obtain the remaining two roots, that is x square plus 4x minus 3 is equal to 0 means x is equal to minus 4 plus or minus root of 4 square minus 4 into 1 into minus 3 divided by 2. This is equal to minus 2 plus or minus root 7. Hence, we can write the roots as plus or minus root 2 and minus 2 plus or minus root 7. These are the required roots of the given equation. Plus root 2 minus root 2 and minus 2 plus root 7 and minus 2 minus root 7. With this example, let me conclude this session. In this session, we just done 2 examples for the theory of equations. Thank you for listening the class. Have a nice day.